AI flagged a DDoS attack, but something didn't add up. Dashboard lit up red, traffic spiked instantly, and the system triggered emergency mitigation protocols. Everything pointed to one conclusion: a large-scale cyber attack. But shutting this down would have been a mistake, because this wasn't an attack, and the AI was wrong. In modern infrastructure, AI systems monitors network traffic in real time. They detect anomalies faster than any human engineer. But there's a fundamental limitation. AI doesn't understand intent. It only understands pattern. And in this case, the pattern looked exactly like a distributed denial of service attack. From the system's perspective, everything was obvious. Traffic volume increased rapidly. Multiple switches reported high utilization. Ports began showing abnormal activity, and packet flow exceeded normal thresholds. To the AI model, this was a textbook DDoS scenario, so it responded immediately. It flagged the incident, it escalated severity, and it prepared mitigation rules. But experienced engineers noticed something unusual. DDoS attacks are chaotic. They come from distributed external sources. They are unpredictable by nature. But here, the traffic was structured, repeating patterns were visible, and internal systems were responding consistently. That contradiction raised the first doubt. Something wasn't aligning with attack behavior. The engineering team went into the logs and immediately noticed something strange. MAC addresses were constantly changing between switch ports. Network tables were updating at abnormal frequency, and broadcast traffic was increasing across segments. This wasn't external traffic, it was internal instability. The network itself was creating the flood. Deeper analysis revealed the real issue. A switch had been misconfigured. This misconfiguration created a layer 2 loop. Now frames were circulating endlessly through the network. Each switch kept relearning MAC addresses. Tables kept flushing and updating, and traffic multiplied exponentially. This is what we call MAC address table flapping. And it quickly escalated into a broadcast storm. To the AI system, this behavior looked identical to an attack. High traffic, multiple sources, system overloaded conditions. But AI cannot see topology. It cannot understand switching behavior. It cannot interpret STP state changes. It only reacts to what it measures, and what is measured was chaos. The engineer isolated the faulty switch. They identified the misconfigured port. disabled it from the network, and forced planetary recalculation. Within seconds, the loop collapsed, MAC flapping stopped, and traffic stabilized across the network. This incident revealed a critical truth. AI can detect anomalies, but it cannot understand architecture. It sees patterns, but it doesn't understand systems. And this wasn't the only case, because sometimes layer 2 isn't the root problem. It's just where the symptoms appear. In the next video, I will show you how a DNS misconfiguration can silently take down an entire production system. If you want real-world networking breakdown like this, subscribe for more. Thanks for watching, and I would see you in the next.